Hello everyone. In this presentation, we introduce a new family of item response models designed for ecological citizen science data. This is useful if you have a citizen science project involving the classification of images of different species. Suppose you want to obtain the latent category and assess how well the citizens perform. You might collect data from many participants, leaving you with a huge dataset. However, there is concern about the quality of this data because of misclassifications. Therefore, measuring participants' abilities is critical when making statistical inferences. In our models, we give more weight to data from more competent participants, for example, when performing consensus voting. Usually, there is a special autocorrelation on the difficulty parameters, and we want to capture it in our models. We introduce a new methodological framework of item response models with application to citizen science. These extensions of the three-parameter logistic model give the probability of the participant I classifying correctly the image J. It captures spatial autocorrelation by means of a conditional autoregressive prior, and it produces estimates of the subject abilities and the difficulties associated with the sites and the species, and it also indicates how much guessing is involved in the process. To assess how well the models perform with empirical data, we try multiple datasets. In this one, by the snapshot of the Serengeti, citizens were asked to identify a species of mammals on images. Some animals are more difficult to identify than others. For example, everyone knows what a zebra is, but species like wild cats are more difficult to classify. The dataset includes more than 5 million observations from more than 20,000 citizens, which is challenging for statistical inferences. We use a divide and conquer approach to fit the model within the Bayesian framework, combining posterior estimates using a weighting approach. Comparing several variations, the model that considers guessing associated with the species and a special autocorrelation on the site difficulties outperform the rest based on live-one-out cross-validation. The approach allows subjects to be clustered according to their abilities, identifying the best contributors and detecting careless citizens. It also allows identification of the most difficult species to classify. This helps producing better training for the citizens. The model also produces meaningful measures such as site-related difficulties, which might indicate, for example, camera-related problems. Summing up, this new family of item response models provide better measures of the citizens' abilities and the difficulties associated with species and locations. If this topic is of interest, you can find the manuscript on arXiv, and the implementation and our codes is on a GitHub repository called Staircase. Thank you so much for your attention and enjoy the rest of the conference.